All right. I think we're going. That looks great. What is up, everyone? It is a beautiful day. It is a Friday. Hopefully, you are well on the way to your weekend. If not, and you're just starting out, and where would you be if you were just starting out? Because I mean, it's like lunchtime here in the U.S. So, um, yeah, hopefully everyone that's watching this is either going into their weekend or on the downhill slide there. And that's what we're doing today. I've got my festive gear on, the my beach gear, because today we're going to be talking about some topics that will hopefully free you up with so much time that you'll be able to take a vacation. You know, like those things where you're not working. Uh, What's up, everybody? Hey, yeah, if you're coming into the chat, I had a couple of guys or a couple of people waiting in chat. Yeah, I'll say hey in the chat as you're coming in. And yeah, we're going through some pretty cool stuff today. I know that there's like most of you that are on this stream and kind of in automation, you don't know what a vacation is, and you don't know how to take some time off, but we're gonna free up some of that space today. We're talking about some topics with going through comfort panel HMIs with Siemens. And if you are new to the stream, my name is Jason Watts. I am founder and CEO of a little automation company out of Alabama, which is in the U.S. And you'll hear me refer to myself as a redneck because, I mean, if you're from the U.S., you know about Alabama. But I'm from Tuscaloosa, Alabama. I've got about 23, 4 years of experience with Siemens drives mostly, but controls, PLCs, HMIs, all of that as well. And for about 10 years there, I worked for a Siemens distributor here in the US as an application engineer. So, needless to say, I like Siemens automation, and you're going to get a lot of it today. I have worked with some other stuff, just enough to really appreciate what Siemens brings to the table. But yeah, so industrial samples, PLC projects with 1200 PLC and HMI. Well, we are definitely going through some of the HMI portions of that, and the stuff that we will be working with the 1200 PLCs. I think it was 2 streams ago. We really went through 1200s, how to get started with them. We started up a project and got some of the basic features with the 1200. And while we'll kind of won't be going into too much of that today, but we'll be going through, maybe if we have time at the end, kind of touch on some of that stuff again. But yeah, today is all about the comfort panel HMIs and some of the more advanced features. Earlier in this week, we had a stream that just kind of introduced the basic topics about the HMIs, how to get them into the projects, how to do some of the like basic like events, animations, things like that, like that'll really get you going in a project. And that is kind of where we're going to be starting. So I'll probably go through some of that, but yeah, we will really be hammering in some of the things that'll really save you time once you really start get going, especially if you're working with like a project that, or at a company to where you're doing multiple projects, either like um, an integrator or an OEM. These type of topics using faceplates and templates and things like that, those are the things that are going to save you a ton of time. And that's why we're just assuming you're going to get to go on a vacation. Yeah. So without that, I'm going to put the headphones on, and we're going to go through, and I'm going to get a little bit of our music going because we're about to start up talking about our our PLC topics and HMIs. And if that music is too loud, like for those of y'all are on stream, please just hit me up and I'll turn it down a little bit. I'm trying to get it to where it's not distracting, but we can add a little bit of life to the stream. But yeah, so if you're coming in, be sure to say hey, say where you're from, say where you're joining us from, and yeah. Oops, sorry for that. And let's get started. Let's move over to our portal window. And if you've been on the stream for a little bit, you will recognize this project. If you're returning, you know kind of what this is. We started this, I don't know, it's probably been 5 or 6 streams ago that we started this project where we were talking about load sharing with a master follower sort of situation, to where you can do torque limiting. We had torque limiting, but still keeping control of it in case you have a sheet break or something. And so we've been building slowly off this project. In the last stream, we went through and added this 15-inch comfort panel. And we're going to be kind of cleaning up some of the stuff that we did previously, get it to where we can compile some stuff. We're going to talk about the faceplates, and we are going to actually simulate some stuff. So one of the things that we went through last week is that, let's see, get our HMI. First of all, let's rename this, because I mean we're following my rules, right? You're supposed to name everything well, and I didn't do that last week. So let's just call it comfort panel. That's what it is. Let's go in and let's clean up some of these screens that we did last week, and we'll start at the root screen. And let's see, I guess what we can do is just go in. First of all, we don't have a template here, so let's say none on that, and let's just do a compile and see what would prevent this from compiling. Yeah, we've got some invalid connection configuration because we had some tags that were not appropriate, right? So, all right, so the best way to get rid of that, and again, if this is the first time on your stream and you missed last week's stream, you're not going to miss too much. You'll still be able to learn from this stream, but you probably want to go back and watch the earlier stream from earlier this week, where we kind of went through all of these like buttons and switches and things, because I'm going to assume that you kind of know how to make the basic features. And while I go through and I'll be setting some of that stuff when we're setting up our faceplates, for the most part, I'm going to make it to where, yeah, we're not really doing that. So let's go through and let's just, I mean, our alarm screen we know works. Let's click the screen 1 and let's just delete this, because I want to make sure. We will go into our HMI tags. And what's going on over here? Okay, so it looks like my might be experiencing some network issues for some reason. Don't know why, but maybe we're coming back. There we go. So hopefully the stream didn't totally drop out, but yeah, it looks like it's coming back. So what we're talking about is we're going to be going through and just trying to clean this up and get it to where we had some of these tags that we made on our screen by just dragging them in. And this error that we're getting is because I drug them in from a PLC that's not on the same subnet as the HMI. It made the tag, but when it made the connection, it didn't quite line up. Like it wasn't able to actually go through. So yeah, for some reason, my stream is really off today. Not sure why, but what we will do, I'll keep watching that. It seems like it's going in and out. Apologize for that. So what we're going to do is I'm going to go through and look at on the info, not info, yes, on the info tag, I'm going to go to cross references. So again, down in your inspector window, if this isn't there, try hitting Control 5 to bring up the inspector window. And we're going to go to the info tab and cross references. And then I just want to actually click on these. I just want to click on the actual tags, and it will show everywhere that tag is actually used. And so for this, I'm really annoyed by the internet. Yeah, so for this, we are going to go through and we see that, okay, it is on this root screen. It's used in some value on this connection. It's used in one place on this root screen. So we can click on this and it will actually go to that property. And we just want to remove that tag so that it's not actually being used in our project. Actually, we talked about that exit runtime. We'll just delete that button in general. And so still go back to info, cross references, analog, and you say, okay, we have this HMI connection too. And so really we're just trying to go through and clear out everything where there are these problems. So we have this root screen button 1, it's being press. So we have this here. So let's just delete this action. And that should clear that. So let's go back there now. And again, you should see that this is updating every time we remove it from the program. So let's go here, click here. It's on this process value for this switch that we had been playing with. Let's just delete that whole switch thing, because if you were on there on the last stream, you'll know that that was kind of a little bit of a non-standard way of setting it up. So I wouldn't want it to confuse anybody on that. And let's see, last thing. I don't think, yeah, this isn't used in the connection. So this should be able to, well, it won't compile. All right. Again, this is kind of part of the stuff to where sometimes you have to go through, and especially when you're like, oh, these buttons were added by the wizard and we deleted the screen. So yeah, this, I mean, everybody that's ever done this stuff, we set tag screen number, yeah. So that should be able, pretty close. Everybody knows that kind of getting things compiled sometimes, especially if you're just messing around like we were earlier, then yeah, sometimes it just doesn't quite work. So the last thing that we got to do, now I know we got this, is we're going to go into our connection. We're just actually going to delete that whole connection, because that connection is invalid. That 1200 processor is not on the same subnet, and that should be the last thing. And now, and the reason we're actually getting it to compile, oh, yeah. The reason we actually are trying to get it to compile is because we want to actually download this to a runtime simulation. And so it looks like everybody's back. If you're still here, you survived the bad connection. Yeah, let's give a thumbs up in the chat for anybody that's made it through that. I do not know why. Live in a great city, but sometimes this building internet is absolutely terrible. But yeah, all right. So it looks like we've got it compiled now. And if you missed that because of choppy internet connection, maybe you could go back. But I was just digging around, getting all of the getting everything taken to where we compile, because we're actually going to download this to a simulated HMI, And we're also going to put a little bit of a PLC program on the back side of it so that we can simulate some analog values and stuff like that. So a couple of the so what we're going to do now is I'm going to go through and show you, this is your first time seeing this, this HMI is connected on the same subnet, this PNIE2. So this is this Profinet Industrial Ethernet 2. And as you can see, we have two different subnets, and that was the problem with that connection. And so we want to use stuff from the CPU technology object CPU. And so let's go in and let's make just, I don't know, like a little thing. Maybe I have some stuff in here. I mean, again, this has been around for a couple of streams, but let's go through and just make a couple of tags and say a tag, an output, and let's do like a seal-in circuit here, like this. Oops. Again, kind of showing you just kind of the, so start, stop. And again, these are just, we'll just go through and name them. Define tag. And again, if you've ever watched any of these, I'm doing this in a way that I will kind of lightly make fun of. But this is a very familiar way of doing things if you are coming from a Rockwell background. You set stuff up, you define tags, and they end up in memory, which works. But everybody knows that if you're a Siemens programming veteran, you can tell that you have a Siemens or a Rockwell user that's programming because they use in-memory a lot. Once you've been using Siemens for a while, you realize, oh, hey, there might be a better way of organizing things than just using in-memory. But for this PLC program today, we're just trying to get something so that we can download it onto the PLC and we can have a little bit of action with the HMI, just to kind of prove some stuff. And what we will also do is we will just go to the tags, and in our default tag table, we will just make an integer called my integer. And we're going to make it an int. It can't do that. And we'll just do m. So it's going to be word 100. Yeah, it's almost like I know what I'm doing. I don't most of the time. I just fake it convincingly. Nah. But anyway, so what we're going to do now is we've got our, I think I have the right one. Where is it? PLC Sim. Bloop. So if you're not familiar with PLC Simulator, I have this set up to be that technology CPU. And the way that you can start this PLC Sim is if you have it downloaded. If you have a portal license, then you have the ability to use PLC Sim Basic. You just have to download a little bit of extra package that's available on the internet. There's details about how to do all of that on another live stream where I talk about simulating PLC Sim. So with that said, you can just click on your PLC and then this little start simulation, you click it and it will start up and it will give you the option and it will link that CPU to the simulated CPU. And so I've already done that. And so now when I can click here and I can say I can go online, and it's actually going online with this simulated CPU. And if I wanted to download these changes that I just made, because I've just made these changes, I would download it just exactly the same as I would with a regular PLC. And so here's a little thing here. And again, this is the same steps that you would be using if you were using like a S7-1200, S7-1500, and this little simulated PLC acts just the same as what you would have out there. So like starting up the module, you'll see that it actually goes from stop to run over here, just the same as if you were flipping that little switch on the front of a 1500. So now we can actually go online with this, and we could say, we could modify this to a 1, it seals it in, modify to a 0, or if we're real fancy, we can do we don't actually have to like click, we can just do like the control, what is it, F2 and turn it on. No, control F3. How's this not working? Oh, there it is. So we don't have it there. So, and then now that's off. So we have our little seal in circuit, and I'm just hitting control F2, control F3, control F2, control F3. So we can do it that way. So that actually works. We have successfully simulated the PLC. Now what we actually want to do is I'm going to go offline on this so my computer doesn't die. Oh, no, it's not too bad. But we're going to go in and add a couple of these little things. We're going to make this start button, and then we're going to do a control C, control V like this, and we're going to make a stop button. And we're going to modify, and I'm doing this very quickly. Again, I went into it in more detail. By the way, what I just changed there, for some reason this was in the property list view, which is a little bit different than what you probably are used to, because by default it's set up like this with the property pages. I don't know why it was like that, but so what we're going to do, we're going to go in and fill pattern. We want to do a red version of this for the stop. And then we're going to go to our event. Oh, didn't even have it. Okay, good. Oh yeah, because we deleted that event. Sweet. So, you're good. You're never late. You can never be late to this stream, because, I mean, y'all are probably working or just getting home from work from a long week of work. So glad to have you here. We're picking up about where we left off. The first part of the stream was just me trying to fix all my mistakes from the previous stream, but decided to show y'all that so that you know that, hey, you got to dig through stuff. So we're making a little box here. Start, stop. We've created a little logic in our PLC that is simulating, and I'm gonna move this off the screen for right now, just so that it is a little bit out of the way. And I'm gonna find a good place for my face. I'm gonna put this like up here, because I want y'all to be able to see all these like basic objects and everything. And I was kind of covering up, and then we're gonna be using the detail view, and all of that. So yeah. So I've got to mute one thing on Discord, because otherwise that will make me go crazy. Sorry. Hold on. Let me just mute this tab. There we go. Sorry, I get distracted pretty easily. I don't know about you guys, but we're getting back to this. Yeah, we got some messages popping through in Discord. I could see some people starting to chat back and forth, so I wanted to nip that in the bud in my brain. So we're gonna have this little start stop. So let's get back to here. We want to have a start. We want to add this function set bit while key pressed. Bit. What? Oh, because it's a click. Not clicked on the right one. So set bit while key pressed. And then we want to, from our PLC over here, we want to use our detail view, like we kind of talked about before. And we want to click on our default tag table and our start and our stop. For start, obviously we won't start. For stop, we're just going to click on it. Same property gets associated with it. So set bit while key pressed. And then we're just going to drag this over. Start and stop. And now let's compile that. Hopefully it compiles. Woohoo! We're programming. So we've got our start stop, and let's make a little bit of another status. Let's just make like a little indicator. Very basic stuff today for this, because this isn't quite what we're wanting to work on. So we're gonna dynamize. That's a difficult word to say. We're going to make dynamic this little thing, and we're just going to make it an output. So we're going to go to our output that we programmed before, LMNOP. We're going to connect this to this appearance property, or under animations. So again, properties, animations, appearance. And I clicked on the little create, like quick create, when we get here. And so for this range, for 0, we want the background for this to be red. For 1, we want the background for this to be green, right? Yeah. Those the same greens? I believe so. So we've got that. And then the last thing that I kind of want to do is, so we'll have this here, and there's a reason I'm going to put like a little box around this. Okay. Kind of showing you a little bit about this. Remember, we just covered up our stuff. By default, when you bring in objects, it lays stuff on top. So the latest object is on top of all the other objects. You just go up here to these layers, select object to the background, bam, moves it all the way to the background. Clean this up a little bit. And I want to do something here that yeah, we have, I have selected the box. I want to make a for this, and then I want to have my integer, because I didn't show this before, because you can have different colors and different ranges. So if you have a range 0 to 99, for example, then let's do this 0. Yeah, so 0 to 10. We'll call this 0 to 10%. We want the background color to be yellow, because maybe we're about to run out. And then from 10 to 90, we want it to be green. And we say oops, because you can't overlap. You have to do 11 to 90. And then from 91 to we'll say 16,000. Then it's going to be red. Okay. And then for our last one, let's do a -1 to -16,000. Even though that should be like 32,000. we need to figure, oh, I probably, I did that backwards. 16,000 to -1. My brain got backwards. Needs to be red and flashing. Okay, so we've got this little manager thing set up, and the last thing we're going to do is we're going to set up or bring this in as this is a, oh, that's a symbolic IO field. That is not what I wanted. I wanted this one. I wanted an IO field, and I'm going to tie this as general. I want it to be an input and output, because I'm going to use this to change that integer value to show our colors. Okay, so I want to tie my integer to this, set as input and output. This is saying that there is no decimals. So it is decimal, meaning it's not in hex format. It's not. It doesn't mean that it's actually using a decimal point. It just means that it is in a base 10 in the format pattern. The format pattern, this will show 1, 2, 3, 4, 5 digits. And so we only need 16,000. Okay, so that is actually right. And because it is an integer, we do not want to be able to put in decimal places. So we do not want to put in tenths, hundredths, thousandths, whatever. So that's good. We're just going to leave this off of here for right now. Actually, we'll put it here. And I'm getting all sorts of stuff cluttered up on my screen. But we're just working with this little tag right now. So let's compile this real quick. And still compiles. That's great. So now we want to actually simulate this HMI. And so what we are going to do is we're going to click on the screen, and make sure that you click on the screen, because we already have the simulation for the PLC running in the background. And we want to start a simulation of this HMI. And so pulls up here, says start simulation. The simulation starts with the start or the screen root screen. And so what we have selected, that's what it's going to simulate. And if we were to have anything that went back and forth, then yeah, you would have this. And what we have down on this screen is our actual 15-inch HMI here. And so now we can, if we have a noted, so it's using a simulated, we can do this 10, and I don't know if that was actually, that actually got connected, but let's see if this connection doesn't seem to be set up. So let's see if it's not quite working. I think I see what happened. Oh, it's because of this. For some reason, my PLC went out of run. There we go. So my PLC dropped out of run, and so that was why I had to restart it. And so we have this, good to there, good to go there. Oh, and we need to go to 11, don't we? It's not 10. Someone's paying attention, not me. So here we go. We have control. We have a fully simulated HMI, and only using like, I don't know, let's see how much of my processor. Oh, not too much, only like 4% of my CPU. That's efficient. But so that's kind of the basics of going through and simulating an HMI. If we were to have something that changed screens, we would actually be able to navigate through the different screens, but we don't have that right here. So let's do that real quick. And I'm going to drag this down onto my other screen here. And so it's just all my simulated stuff is sitting down on this other screen. Let's add in a way to get to our, so we're going to put a button like this. And then we're going to say alarms. And then on that button, properties, events, press, activate screen, and then we're going to do alarm screen like that. Okay. And when we click on that, that screen is not going to have a return to get back to the root. So let's go ahead and add that. You can definitely get lost in this project view if you're not careful. So on this alarm screen, we need to open it up and make sure that at the bottom we have a way to get back to our home. And this is button animations, so press, activate screen, root screen. And now we can compile that. And then now download. Instead of doing that, let's just do this. Let's just close our HMI. Probably going to be a better way of doing it. And then starting it again. And it seems like when you close, I'm looking at when you close and activate the HMI, you have to start the processor. So here's this home screen. We can click on it. It goes back, go to our alarm screen. So here's the fact that you wouldn't actually be able to run this, because this is actually using a kind of a temporary version of, there's a little WinCC runtime on my other screen that says too many tags, power tags have been configured. So it's letting you run it, but this wouldn't be able to continue to run because it's using WinCC runtime, which is kind of like a SCADA Lite version. And so that's what's going on here. So we have here, we still have our start, our stop, and well, we don't want to do 100. We want to do, actually, we want to put in -10, right? Because we want to flash this. And this is what I was talking about. Operators get really annoyed by flashing stuff if it flashes all the time. So this is why I told you in the last stream, don't ever set default something to be flashing, because you want people to like you in life, right? So yeah, let's put this on 50 and we're good to go. Start it, stop it. So that's pretty basic. And again, if you're in the stream and you've got questions about something on this, like, go ahead, type them in chat. If this is the first time you're joining in, always I'm open to questions, open to things, and in general I can answer in some way most of the stuff. And I also have zero problem telling you that I don't know something. But here's the thing, I'll tell you I don't know something and then I'll go try to look it up for you. Because one of the things about Siemens is there's a ton of stuff out there and you're not really expected to know how to do everything. And so you kind of have to learn where stuff is and learn who to ask. And so in my experience of my eight years of experience in Siemens distribution, the biggest thing that I learned was who to ask and where to get the information. So don't feel bad if you don't know something. Always, it's always a good policy to be like, to learn how to say, oh, I don't know that, but I'll figure it out. So, and if it's a first time onto the stream, welcome. Hope you're enjoying it. Hopefully you've noticed that there's a lot of extra information about Siemens programming and just general automation topics on this channel. So explore that. And if you like what you see, hit that like, or the like and the subscribe button, because we are growing. And as we grow, we're reaching more and more people and getting more and more content from you guys. So the next thing that I want to do, so I'm going to close out this simulation, is I want to talk about faceplates. And faceplates, we kind of mentioned them on the last stream. We didn't really get into them because there's kind of a lot that goes into them. just conceptually, and I wanted to be able to make sure that I could go through and explain everything to you up front, and honestly, I had to refresh a little bit about the best way to kind of get started with faceplates. And so what I'm going to do is I'm going to move my face again and put it on a plate. Joking, right? Face. Never mind. But the basic thing about what a faceplate is, say for example, I have this little start-stop circuit here, and this is a set point value. Let's add in just some text that says set point. Okay, and I want to align this up. There we go. Actually, that lined up right? Yeah, it is. So I've lined this up, and I have this little block, and say this is what represents a motor in your plant, just a manual motor starter. And you could go through and say Control C, Control V, and then go through that and do that. You could even go through and say, all right, I'm gonna do this, and I'm gonna right click and say group, and then now even if I click off and click back on, it moves as a group. Cool little thing I didn't talk about, grouping. And then inside your properties windows, inside of a group, you have this extra little thing to where all of the individual properties of that group, or all of the individual pieces of that group, you can expand out their properties. So that's grouping. And you can Control C, Control V a group, and then go in here. But if I wanted to change, like I'm selected on this group 1 group, okay? So this copy. If I wanted to change the button 4 event, this press, and change it to a different start tag, because that's the start for the logic that's up there that we did earlier. So that's the same logic that this guy's on. We have to change all that. So you'd have to individually go through all of those and set all of them up to where all of those properties are, it's set individually for each one. That might be fine if you have 2 motors. What if you have 200? And if you're running into something like that, you're going to immediately say, hey, this is going to take hundreds of hours for me to be able to go in and change all of these tags. Even if you're lightning fast, it will take hundreds of hours. And so that's why I'm wearing the vacation, because I'm freeing you up for those hundreds of hours this week. So I'm gonna delete this, because we're about to make this, instead of just a group, we're gonna make this guy a faceplate. So I've right clicked, and I'm gonna say create faceplate, and it starts trying to kill my computer, and it says, hey, we're adding a type. And if you've watched any videos on here, you've heard me talk about using a type. I use this sort of stuff all the time, and this is kind of moving into the next level of your kind of automation and engineering journey, is by starting to use these types. And so I'm going to call this, the name of the type is going to be standard motor control panel. Oh yeah, so RAF, that's awesome. Yeah, so one of the things, kind of RAF, this is kind of random, kind of bringing up a point about Profinet. Profinet works over wireless, and I mean, it doesn't have to have a very specific version of like a protocol or a router or anything like that. The thing about it is, if you're coming from the US and you're like, hey, I'm trying to learn about Siemens, you may not realize that Siemens is the largest automation manufacturer on the planet. And they're so large that they sit on the boards of like all of these other places, like Profinet. You might say, oh, that's Siemens version of Ethernet IP. No, Profinet is its own standard that's like separate outside of Siemens, but it was created by Siemens, and now it's this like international standard. Well, because of that, built into the TCP stack, which includes like wireless technology and all of this stuff, built into the TCP stack, there's actually a little bit in there that is used by Profinet. So even if you went in, and I would not recommend doing this, go into like Walmart or somewhere that just sells like your regular internet router, like a Linksys router, you can use a Linksys router to run Profinet communication. Now, will that stand up to the test of time in an industrial environment? Probably not. But you can kind of do all of these connections and everything over wireless. One of the cool things about it as well is that there is the ability to be able to do safety over wireless as well, because just like you have Profinet, you have Profisafe, which is just a little bit of extra communication built on top of that Profinet protocol. And so you can actually have, there is a wireless HMI unit that is designed from the ground up, and it has an e-stop on it. Oh yeah, yeah. So yeah, the downloading and uploading. One of the things that because Profinet is so flexible, and even the connection going across to it is, you don't even need to be, you just have to have what's called a network path. So this kind of opens up whether or not you want your IT department involved in it, like is kind of it. But these like secure IT principles that are networking principles that you really need to be paying attention. The Profinet kind of like lets you use all of those tricks to be able to navigate and go through. So for example, RAF is talking about being able to download and upload over just a standard Profinet and standard wireless. I live in Atlanta, which is in the Southeast United States. I have plants that we've put in all over the country, and we have secured VPN access to those different plants, and I'm able to connect up to those processors through our secured connections and connect up to them sitting here from Atlanta. And you would be able to do that too and not only is it over a wired connection, the ones that we're using mostly are over an LTE connection. So we have it's a program that is by Siemens. It's a VPN kind of manager called Cinema Remote Connect. And Cinema Remote Connect uses the Scalance hardware for Siemens and creates these secured connections. And so you're able to download and do all of that stuff over that sort of thing. And so, yes, all of these connections that we're doing, as long as you have a good network path to the device. And what will happen is sometimes when you go over a wireless network, the wireless device is not hooked or not set up correctly to not filter out that. So it has its own firewall in the wireless device. You come in wirelessly and it gets firewalled out, and it doesn't quite access onto the network correctly. And so if you're having trouble connecting up through a wireless connection, that's most likely what it is. There is the wireless connection needs to be set up as like an access point, and essentially puts that wireless, everything that connects to wireless has to be on the same subnet as what's called your OT, your operational technology network. So the actual network that is all of your PLCs and everything are on. And so there 100% is a way to communicate and connect wirelessly. You just have to have that subnet path set up. So hopefully that ping the HMI IP address was grabbed on a laptop. Yeah. So if that is the case, RAF, then you should be able to connect and download and upload through that connection. If you're wirelessly on that, and the way that you would do this, I'm gonna have to go back to visualization. We'll go back to Faceplates. Again, all of this stuff is for you, and when you're coming on here, we might get a little bit off topic, but you're gonna get the information, hopefully, that you can. So if you go to download this, it brings up this screen. By default, and the reason it's not, so the configured IP address is the one that you would be on. So this even has DNS. So you would no RAF, that this is exactly what we're going to. For some reason I can't select my different PGPC interface. Probably what is going on is you have to, in this PGPC interface, select your wireless card instead of your actual LAN adapter. And so normally, let's see if I can get this. I don't want to close that out, but so normally that we're gonna extended go online. Yeah. So here, oh, it's because I have PLC Sim activated that it's doing this. So right now I only have one option. Let me just cancel it. This might regret this. Regret this later when we try to start it up, but it's definitely worth it to show you this, because here, extended go online, right? This PGPC interface is the actual RJ45, so that's my Ethernet cable adapter. You have to, if you want to connect via Wi-Fi, you have to select this manually. So this is my Wi-Fi. Okay, TIA V15, this should still work the same way, because this is a network path issue. Always click on this connection interface. Make sure that it's on the subnet, because sometimes it'll act goofy if you select like direct at X1, direct at X3. Always select this subnet, because if you remember, on our devices and network, we have that Profinet Industrial Ethernet 1, Profinet Industrial Ethernet 2, and so you want to select this. So here is how I would do this. And if I was connecting over Wi-Fi and like my laptop could ping the HMI, you would have to do this, because the laptop is automatically going to select the correct network path. It has its built-in routing, whereas TIA Portal doesn't have that like automatic routing from the hardware standpoint. So you have to tell it, use your Wi-Fi adapter, and then look for it on Profinet or on the subnet. And it should, I mean, mine won't. Start search and it does this. So I was talking about that VPN connection. If you are kind of using that same principle, the VPN adapter sets up this thing called a tap Windows adapter. And so TIA Portal thinks that it is another network card. And in order for me to connect to my remote connection, first I have to go into my little client, create the connection, and then I can go to this tap adapter and then do the same thing and then do the search, and it will go through that VPN connection and try to use the find on the subnet that way. So if you're using wireless, you have to use this Wi-Fi. And yeah, that's the same for all versions of Portal. So I would try that RAF. If I had to guess, that's it. And since you're able to ping, you're on the correct subnet. But like I said, that laptop will behind the scenes pick to go over Wi-Fi instead of trying to go over the Ethernet adapter, whereas this one won't. So we're just going to cancel out of this. Hopefully that helps you. But yeah, so let's kind of, no problem, RF. And yeah, as always, if you have a question, like we're doing here, it's back and forth. It's one of these things to where we're working through stuff together. Some things they're straightforward, but unless you kind of understand how TIA Portal does something, then how are you going to know? How are you going to know it? So there are no bad questions, and especially always be willing to ask questions. The one thing that's going to hold you back in your journey is if you're afraid to ask questions, and that's coming from someone that has a little bit of success in the industry. And when I see people that are like really smart, but they aren't like fulfilling their potential, it's because they're afraid to ask questions. So like it sounds kind of weird, but if you can get away from like what people are going to think about you, if you can get that out of your mind and say, hey, I just want to be better and to get better. And honestly, if someone thinks bad about you for asking a question and trying to learn, that's on them. That's their heart and their mind and their character. That's not on you. So always ask questions. And after the stream, if you're watching this, you're watching it on demand, feel free to drop a comment with your question, and I'll go through and try to answer them. So let's go back and kind of go back to this library. So what I did before was I went and created a type of this standard motor control faceplate. Okay. And it looks like because I drug this type in last week from my global library. No, Lucid, you definitely never derail stuff. So Lucid's asking, is there any downside to establishing HMI connections to multiple PCs instead of transferring data over an S7 network via PLC to PLC? Let's kind of go through that thought. So let me see if I can get this up. So Lucid, that's a very good question. Let me get this going here, because what in essence is like, when as an automation engineer, you are always wanting to say, hey, what's the cost of what I'm doing? What's the gain of what I'm doing? Because we're all about efficiency, right? And the root of this question is whether or not having a connection to let me get paint. Let me get this sketch pad pulled up. So the root of this question is is, all right, say we have two PLCs. And we have PLC 2. And we have one HMI. Okay. What is better? What is better? Going through and making two connections like this? Or is it better to make this two-way connection here, pass the information back, and do away with one of these connections? Is that kind of what I'm understanding, Lucid, that you're asking? Because that's a pretty valid question, because it kind of depends on what you're doing. So this is kind of option 1, and then this is option 2, like this. And so in option 1, let's clear this, that. So in option 1, where we have our HMI connection, you aren't using up any resources on the PLCs. So if you are only wanting to display values from multiple PLCs and you're not really wanting to interact with anything, if you're just displaying something and you're okay with about a 1 second update time, then this is probably the best way to do it. Because what this does is it takes all of your software load and puts it in the PLC, or puts it up in the HMI. And each of these PLCs consumes one HMI connection in its resources. And really that's it. So like from a resource perspective, this is, from a PLC's perspective, this is the best way to do it, because there's this connection channel that's built in specifically for the HMIs, that doesn't it does impact the PLC, but as long as you aren't using a ton of it, then you're not really suffering any consequences, because there's some reserved resources there that if you don't use them, you just don't use them. You don't have access to them. So, and usually you can have a couple of those no matter what. So that is kind of, if you're just looking at stuff and displaying some motor statuses and you're not having to do anything quickly, then this is probably the best way to do it. In option 2, where, say, like in our project that we've been working on, this is a 1500 PLC, like a 1500 TF. So this is a pretty good processor. And this is a 1200. Okay. This, and you're wanting to pull data and process it and then make some decisions about it quickly and then be able to kind of back and forth. That is where you would want to have a connection here, because it's all in what you're doing with the data that you're passing through. If you're trying to do some sort of control and you're trying to kind of rely on this information, kind of not real time, but in essence real time, you're wanting this connection. you're wanting the PLC to PLC communication. And if you're already doing that connection and you're already pulling that data into a, a, a faster, higher performance PLC, like this example here, then you don't want to consume an extra resource on your lower end processors, because this communication is more vital than your HMI communication. And so in this case, you would want to only have one connection down to this, have a data block in here that's my 1200 data, and then just send it through that. And then that way the 1200 doesn't have to worry about getting pinged from an HMI and getting anything like that. This is kind of the most efficient way if you are trying to do a fast process. And honestly, this is kind of how I just in general like to do things, is because the software load up here on the HMI isn't really going to change if things down here, like anything down here, either here or here, like if any of that changes, then the software load on the HMI really isn't going to change a bunch. Yeah, you'll add in some, maybe a template, like we'll be doing here in a second, or a faceplate. But this goes into the fact of like, okay, how big of a change is it going to be? Like, what's the performance impact? So to like answer your question in just a simple sentence, Lucid, it really depends on what type of performance you are looking for at the process level. If you have all 1500s and you've got plenty of resources, then it's actually not going to make a difference, because this HMI connection is reserved, and then this S7 connection is different reservation. Now, if you're using, if you use a put and get block instead of a what is it, DP, or sorry, like a TCP. No, it'd be DP. Like a DP read, and then like a DP write. Which, by the way, I have videos on those if you don't know what those are. Look them up on the channel. If you're new to the channel, like and subscribe, all of that stuff. But if you are using one of this is going to be an S7 connection. This is actually going to come across as a HMI connection. And I'll show you here in a second that these are two different connection resources. So they're separate, and there's some that are reserved by default. And so if you have a bunch of HMIs that are trying to load in, you start getting into the situation of like, okay, if I want this process secure, then that's where you want to try and use that S7 connection, because it is a separate connection. So yeah, that is a pretty deep extraction of information out of my brain. Hopefully that didn't confuse you more, Lucid. But yeah, now you're probably asking even more questions. The answer to my question causes more questions. So Lucid, does that kind of get you? I'll show you while, or kind of seeing if that's okay. Let me, I'll flip over to this other screen and I'll show you. If we go here, for example, and we go to our CPU tech. I believe it is under program info. Our resources. Here. Sorry. There's a lot of stuff. Has anybody ever noticed that there's a lot of stuff in TIA Portal? Maybe it's under our device and networks. If you know where the connection resources can be found, throw it up in chat. You'd be a hero. Is it this? Nope. Nope. There's a place where it actually tells you the available connection resources. A tab to the right. Talking about device view. Then going in here. See, Lucid's teaching me. Info. Anyway, there is a place. I may have to write this down to do a short on it. There's a small arrow in the network view. Oh, this guy. Like that. Is that what you're talking about? And then in like properties, general, something like that. Connections. There's so much stuff in here. Well, is this what you're talking about? Like the actual in here? Well, Lucid's like, yeah. Lucid's gonna like yell at me the next time I see him. I think I'm gonna be over there next week, so you can yell at me in person, IRL. But yeah, so yeah, this, you have these sorts of things, but this isn't quite what I was looking for. There's a place to where it actually shows you the number of there it is. Ew, I just didn't scroll down far enough in the first one. So click on the PLC and then go all like into properties down to connection resources. And so this actually shows you how many reserved connections you have. So by default, you have 4 HMI connections that are reserved, and then you have your S7 communications that are different. And so we were kind of talking about the puts and gets. It uses this HMI communication, and so it'll use up one of those. And so right now I have these 2 HMIs here, and so that's why it says that there is 2 configured. And if you notice here on this, there is a maximum number of resources for this station is 10 for these kind of station resources that are reserved. So you can have up to 10 of these without it being affecting any of your performance. And so this is what this dynamic is. It can have up to 98. So you're looking at over 100 connections that are possible to be able to actually use. And so at minimum, to no cost of your performance, you can have 4 HMIs, and then you can configure in some of these extra S7 connections, and you're not gonna have any cost. And we can kind of click on this CPU basic. Let's see connection resources on it. So you can see that the kind of the way that things are done and shifted around are a little bit different. They have some reserved S7 communication paths on a S7 1200. They have a bunch more, but overall, there's going to be a lot less connection resources available. And so that's a 1215, which that's like a top end 1200 is going to be like a 1215, whereas a 1515 is going to be a mid-level processor in the 1500. So yeah, those are connection resources. So to answer, kind of going back to like this little sketch thing, is if you don't get outside of these reserved numbers, then it doesn't really matter how, like, you can have these 4 HMIs on here and it will not affect the performance of your process or your processor. What will affect it though is if you're not getting your data and you're not getting your updates and you're not kind of getting your exchange fast enough, and that's where your S7 connection comes in. So a little long-winded on that. Sorry about not finding that. I was close to it. I thought I knew where it was. I just didn't go far enough down at the beginning. So again, showing you that even if you've been using this software for years and years and years, sometimes it can get a little like you lose track of stuff. So don't ever feel discouraged when you're going through all this stuff. So let's get back to our discussion about faceplates. So faceplates are kind of a part of our library functions. And for this, I'm going to move over here. Part of our library functions, because there's a tab over in this far corner or on the right side for libraries on almost every screen. And in that, you will have your project library and then an option for global libraries. And there's some global libraries that I have that are like buttons and switches, long functions, stuff like that. Well, if we go into this like buttons and switches, it opens it up and we start digging into master copies and things. And what's cool is you have like diagnostic buttons, comfort panels. What is this? Let's see, diagnostic indicator. Ooh, that's cool. And these are all faceplates in these like lever switches. Lever horizontal, vertical. What's this? Ah, this is like a tick, tick, tick switch. So this is kind of built-in libraries that are part of Siemens libraries that you already have. Well, we're going to be making in the same way that these have built-in functions and all of this stuff. We're going to make this into a faceplate in the same way. And eventually we'll get it into a global library. I'm going to clear that out. And we've made this faceplate here. And you can see where it says that it is in work. So we have our version 0.0.1, which when we right-clicked and said create faceplate, the little screen popped up, said, hey, name this thing and what's your first version. You can start it out at version 1.0, but we're going to call this like a alpha version of this faceplate because we know we're going to be making changes to it. And so we're making changes to it, so this is in work. So if we double click, or I guess I should say, you say open, it's gonna slide over and bring us up the library view. And this is where we were actually editing this faceplate. And right now, what we have is our buttons. Actually, we just have a group. And so the first thing we're going to do is we're going to right click and ungroup everything. Because at this point, when we use this in our in our faceplate or in our HMI design, when we drag this over, all you can do is modify the interface. You can't modify anything in the faceplate without going over into this, what's called the library view. And yeah, so my face is in a good spot here. So what we want to do though is go into and set our events up, right? Well, the thing about it is, let's see, configure connection with drag and drop. And I'm going to be honest with you, I'm going to have to kind of work through some of this stuff because we want to make sure that we have a, because in the interface, what you're going to do, and I didn't show you this, is you will have essentially a thing that says, hey, you got to give us these values. You got to give us a start, a stop, and an output, and you'll see all this. So we'll want to do like a press and events. Yeah, so let's go through and and again, probably should have went through and refreshed on all of this because again, I've made the stuff that I pulled in a long time ago. I pulled those in and I did those last year. And so actually, no, I did those 2 years ago and I've just been using them. And once you have that interface set up, and we'll be talking about like PLC data types and stuff here in a second, hopefully. So let's see if we can go through and configure connection, drag and drop. Press, events. No, this is our interface. I think I don't have everything that I need. Yeah, that was the problem. I didn't have the right thing done. So I can go into and click here. Yeah, we want to kind of minimize this out for right now, because what we want, this is what we're used to, right? We want a press, we want a set bit while keep pressed, but we have to have a value here, and in order to get a value, we need to have something that we have access to. And so in this thing, we want to get that from the interface. Let's see if I can remember how to do this. And it's in here. So we want tags. Then we're gonna have our like that. Then we want to add a new one, and then we want our now. So essentially, what we're doing here is we are creating tags that are available to our template, okay? And then later on, we will tie our actual tags in our system, because remember, you're gonna be pulling this out of a library. And just like if you're familiar with the whole function block, and I've talked a lot about making good function blocks, you wanna have everything in local memory. You want it to be set in local memory, because that means you know it is there ready to go. And if you don't quite know, there's a couple of different videos that I have out there, check those out. But yeah, so we're setting up what is essentially local tags that no matter what program we pull this faceplate into, it is going to, those tags are going to be available. And I'll show you what you have to do with those on the other side here in a second. So we had our start input, our stop input, our output lamp, our set point in, because those are kind of our things that we're trying to mess with. And so now what we can do is when we click on this, we should have available to us our start That's our start input. And then here we can also just do press set bit while key pressed. Stop. Whoops. Up. Again, so we've got those. We can pull those down. What we had on this, an animation. And so again, we're having to go back through and set all this up, just like we would kind of have to if we were doing it originally. So we want this to be our output lamp. Range 0, we want our background color to be red. Range 1, we want it to be green. Not that green. And so we got that. We don't want any of that. We want this to be set up. Properties tag is our set point. We called it set point input, didn't we? Oh, so we do need to go back and change this. We didn't change that to an int. Y'all didn't catch me on that. Are y'all paying attention? I'm messing with you. Being able to pay attention to me should be like a skill that you could put on a resume. I'm able to survive and pay attention the entire time to a Jason Watts AE live stream. You're hired. You're hired. So we've got animation here. First of all, we wanted to set up this guy, right? So in general, set point in, analog input, output. That is not going to be a binary. That is going to be a decimal. Format pattern, we want it the same thing. We want it to be 1, 2, 3, 4, 5. Don't want any decimal places. We've done that. We want to set this up. Animation, appearance. We're going to do set point in. Range, we're going to do the same thing. Negative 16,000 to -1. Background color is going to be our red and flashing. From 0 to 10, it's going to be yellow. 11 to 90, it's going to be green. 91 to 100, it's going to be, actually we're going to do 90, we said 91 to 16, whatever, because an integer, so the reason, if you're asking a question, why am I doing the 16,000, I should be doing the full range of an integer, which is plus or minus 32,000, because what can happen is, yeah, the range, you have to kind of range limit your values that are going into it, but I'm not doing that. And so I'm trying to just cover a range outside the actual possible values of a range of an integer. So yeah, that's what this is. And this was going to be just regular red, no flashing, right? So we're going to save that. And I think that's it, right? So we got start, event, press, go, stop. Yep. Got animation on this. Output lamp 0. Yep. Animation on that. Probably right. And then tag property on it. General. Yeah, it's good. So got that. Now we've saved that. And now let's see if we can. I think that is enough. So let's save that, and then now let's release this version. Then we're going to say update instances in the project, and now we're going to go back to this, because this is now standard motor control panel, right? And We haven't. All right. The interface isn't connected. I gotta connect this. We gotta go back. Dang. I didn't connect that right. So we're gonna be using this interface here and then select the tags that are actually getting passed into that value. So we've gotta go back. Again, it's been a minute since I've actually done this. And so we want our tag. What am I doing? It's right here. I just can't remember. Interface. If we drag that over. I feel like it's here. By the way, we can, one of the things we were talking about, setting our ranges. We could set an actual range for a value so like on this set point input, we can actually go through and set these ranges just so we're not having to worry about our what's it called, being able to cover all of our edge cases on our stuff. So let me see if I can remember how to use this screen. Configure connection with drag and drop. Our interface. Yeah. So this is what I was wanting. Yes, here it is. Maybe this is how I actually probably should have done it. Property. So yes, this is actually what I'm supposed to be doing. I knew I was supposed to be doing this on this screen. So this needs to be Boolean. And instead of using the tags, because those tags are something different. Sorry about this, guys. Add new property. We'll edit that, and then I want it to be. And so here is where we actually want to go through, set this up, and then add new property. And then now I should be able to tie that stuff to these things. Right? Events, press here. And instead of it being in the tag, there should be in the actual interface now. No. This is the interface. This is what's coming in. And this is order. Oh, it's so close. Yeah, I feel like I'm missing it up here. The problem with this in the template, and you see what I'm struggling with, and if I'm struggling with it, don't feel bad if you struggle with it. There are a couple of good videos about this interface, and I'll probably take this and cut it up and put it together in like an actual edited video, because it's so close. Because if we release this version, we'll go out here, and this will, in its interface, it has our start stop. And then you can go in and say, like drag these tags from your PLC. So let's just do this. Let's look at this. Edit type. I want to see how this is done, because this will answer it. Category 1. And then like if we click on this, there's an event animation. We go there. Yeah, single bit. There are no tags. Yeah, that's what I thought. So instead of using these tags, these are not what we need. And then we select here on our press. It's no longer there. We won't start. There we go. We finally got it. Stop. This. We want the properties for this, animations, output. Set point. Property. Sorry, animations. So I'm just going through and changing all of these things that we set up to the interface, just like an interface into a function block, like we talked about before. Those are coming in through this kind of like configurable interface. So you tie things in. And so what we're going to do here, I think that's it. We should have everything on here coming into, yes, the proper place now. Yes. So we're going to release this version, which is version 0.4, and we're going to update that. And now when we go back, we'll actually be able to do what I was trying to do this whole time if I had my act together. So now when we click on this block, we no longer can go into the individual pieces of it. We can only have access to this interface. And this is where, though, we can go in and tie our actual tags that we have created up here, default tag table. So our start, which this has the connection to it, this is where we're actually making that connection. So we're just going in the dynamization, and then, except I put the wrong one. So output needs to go to output. Set point, my integer, needs to go to set point. Start needs to go to start. Stop needs to go to stop. So now let's save this. Let's see if we can get everything started back up. Hopefully I haven't lost everyone. If you're still here, hit thumbs up in the chat, because you're the hardcore. You're the ones that could stick through all of the hard times. And you're the real automation people. So let's go through and let's see if we can get our PLC started back up without crashing everything. So PLC, let's get this going. And again, this is kind of showing you how to start up a PLC sim. I'm saying, okay, yeah. And this process I didn't show you before. Oops. Because I'd already done it off stream, because it kind of sucks getting everything started up live, but good. So we're going to do this download. We're downloading the PLC because we still want to test the operation of this HMI, right? So we want to start the module, finish. It's working. And so now we want to click here that we've updated this. And so hopefully we'll be able to get this HMI simulation working like it was before. And that comes up. And we got this. So let's try going to 50 on it. All right, there we go. Start, stop, and go into, let's do -10. And yeah, so there we go. So now if we wanted to add another one of these in, we would drag from our, I'm going to discard changes and delete on this. I don't want to mess up my library. So now if we wanted to bring in another one of these, we could just take from our library and say, I want to bring this in. And then we go to our, click on it, properties, interface, and we set up our, drag in our tags, right? That's all we have to do. So that is the core feature of a template. And so if we wanted to, at that point, go through and make our template and do 10 different motors, yeah, we could just drag them in, or we could do like cut or copy, paste, and drag them in and do that. Now, the next thing that I want to do is take the time to talk about how a PLC data type actually helps you out even further with this whole like saving your time. Remember, our whole objective today is to get you to where you can take some time off because you've earned it. And so we're trying to save you a lot of time from this. Right now, we've saved you a good bit of time, but we're still having to drag in individual inputs and outputs on this. What if we had a function block that had an output that was already designed to give us all of this information here? That'd be pretty cool, right? Well, that's when we can start thinking about status words. So in my agriculture programs that we have, I have a status word that puts out everything that's needed in order to configure into a specific type of that faceplate. So my function block was already set up, and one of the outputs from that block is just straight up a status word. And in it, it has all of the things to make all of the little LEDs going through. Or LEDs, little lights, status symbols, all of that are all available just by pulling in one word into it. And the way that you can set that up, and for a start and a stop, what would be the best way to do that? If you had that, you would really want to have a static inside your function block. Okay, so let's talk about this for a second. Let's go back to our main control here. All right, so we have our little input output situation going on here, right? Well, what if we went through and instead of doing all of this in memory, let's make a quick function block to interface into our pump control or starter control block. Okay, let's do CPU program blocks. This is where this is. Let's add in a new block, new function block, and we want a function block called basic starter control, and it can be whatever number in here, it doesn't really matter. Okay, and in it we want we know that we're going to be interfacing this in with this function block. Okay, but we've got some push buttons out in the field as well that we want to do. So we'll have a start input, stop input. We know we have an output, or we have a set point. Set point in. It's an integer. Okay, so this is kind of like looking like all the stuff that we would have, kind of like on our display, right? And we would normally be thinking, okay, we're gonna hook up all of these into this individually into this block. Well, that doesn't really help us save any time, right? What we would really like to have is one place that the HMI can interface into this block to where we have one custom PLC data type that we can use for our template, and it has everything available to us so we can drag that one thing in. Show you how to do it. First thing we're going to do, because this block, we would want to do the same logic that we had before, right? Start, stop, our output. We'll do our seal-in circuit. Come up here, right? And then this time we would do start, stop, our output, right? And then take our output here as well, right? Same logic that we had before. And if you notice all the hashtags, that means it's all local memory. So this is going to be a function block that copies over. But we would still have to drag each individual one over. So I'll show you how to tie inside your function block to make it to where your faceplate will interface into that just with one point. So we're going to make a PLC data type called my starter faceplate interface. Okay. Okay, and it comes up, and we know we have start in, and we're doing the same thing. And you're like, Jason, why do you keep writing the same thing over and over again? I appreciate it, man. Like the shirt is signifying where we're trying to get. We're trying to get to a vacation. We're trying to get to a beach, and we're trying to save a bunch of time by using faceplates and function blocks. And so that's what we're doing here today. Output, and then we're gonna have our set point. Okay, so we're putting this data into our PLC data type, right? So we're gonna do this, and in our function block, we're gonna set up in our static memory, because we want that to all be in one place. We want to be able to do that. We want to put static memory, and I want to say like my interface, and the type instead of this is now going to be of type, maybe all the way down at the bottom. Yeah, my starter faceplate interface. Okay, we do that, and now I have one place that kind of controls it all, right? So, but we have really two kind of things that we're trying to do to like signify all this stuff, right? We're trying to control something physical. We have physical push buttons. Then we have this HMI interface. So we really need to put this stuff into parallel, okay? Because we want to be able to stop it from the push button, and we want to stop it from the HMI. We also want to start it. So we're going to have an OR. Remember, OR logic in ladder logic is in parallel contacts, and logic is in series. If you aren't quite familiar with those terminologies, I've got a introduction to kind of digital logic and basic computer architecture stuff. We did a live stream about it. You should go check that out. In the meantime, like this stream, and maybe go like that one if you're watching it. But so we're going to put this other new input, this start input from our interface, and we're going to use it as well. So we're putting it in parallel with our, look, I gotta get that out. So we're putting it in parallel. So now if we hit the physical start input, or if we hit the HMI interface start input, it'll go here and it'll activate this, and our output's still sealing it in. But we want to put, hey, if, remember, it's inverted logic, so if you invert the inputs of a digital logic, then it becomes an and, right? So it's a not ors equals an and, right? So you got to go, and we're going to put our not, and then we're going to put our stop from our interface here. And then at the same time, our output, we want to do another output, but it's just going to be our display output, right? Because again, we're trying to set this up to where we pull one point over into and drop it, right? Because that saves us, if we have 10 different display, 10 different tags in every faceplate, if we set up this one thing in our interface, in our function block, then we're going to be able to drag this one tag over into our faceplate, and it populates the whole faceplate instantly. So it's taking a little bit more work up front, but saves you enough time for a vacation. So we've got this is the same logic, and honestly, we haven't been using that set point, but for anything other than just the kind of like display stuff, but it's there now. So now that we have this, our logic is actually connected up to this. Let's bring an instance instead of all this stuff here. Okay. And this is gonna, instead of having all of this, so this is an actual output, and that's really what we're trying to control, right? And if these were actual inputs, then we could use them. But what we want to do now is we just made this function block, that this basic starter control. So let's drag this into our program. And if you notice, it gives it a data block, and this is our motor 1 control. We won't, don't do it that way. That's a terrible name. Motor 1 control. And the reason we want to name it this way is because the next motor that we put in, we're going to want to name motor 2 control. And if you're not familiar with the way function blocks are, I've got a video on it. But it's just, every instance that you pull this function block in, it's going to have another data block associated with it. And so we're just naming those data blocks because that is where we're going to pull our tag, pull that tag and hook into our faceplate. So motor 1 control, we can do that. And now instead of having this logic up here, we really want to pull this output, this Q output, put it down here. We want our stop input to be pulled into here, our start input to be pulled into here, and then our set point we haven't even really used. So now we can just totally just delete that network, because we just replaced that network with this block that has an interface built into it using a PLC data type to our faceplate. So again, a little extra work, but it's about to save us a ton of time. So we still got our simulation running, but so we'll go ahead and download this to the PLC, simulated PLC, do that. And it has gone out of run mode. So we're going to start it back up. We're going to finish that. Now let's go in and modify our faceplate one last time. Let's go. Let's go to our library, and then instead of right clicking on that thing, let's just go straight into our library view, and then it does the little whoosh, and there we go. So let's go in and we want to modify this now. Okay. We want to edit this type, and we've got version alpha 0.5 is now in the works. So instead of these individual interfaces, so this is still in this properties and in the interface section, we want to create a new property called motor interface. Okay. And the type is going to be, okay, so it doesn't have it in it. So you notice here that it doesn't have our new PLC data type available to our faceplate. So what we have to do first is get that into the library. Because this library doesn't currently have anything that it needs. So I have a folder in here called Data Types, and I'm going to take this data type that we just made, and I'm going to put it into my project library. Okay, and it creates a type now of the data type, a type of a type. So we're going to put that in here. Not going to modify it, but it now has a version. And now if we go back in, we should have availability for this for a motor interface. My starter faceplate right there. Bam. Okay, so now we just have to go in and in our faceplate reassign all of these to this motor interface instead of these start stops, like these individual interface bits. So let's go do that. And again, if we'd have done this going in, again, when you're laying out this sort of stuff, you want to think from the end product and kind of work your way back and say, hey, what's the best way for me to have this end product and go forward? Not like, hey, what is the easiest way to do my function right now? Because what will happen is you will end up redoing code like we've done. We've redone this code 3 times now in order to get to this. But now that you know the end product, you're going to know how to set this up from the very start to where you can get that vacation you deserve. So let's go through and modify this stuff one last time. So properties, we've got our events. We want our press to not be from start. Now that is going to be properties, motor interface start in. And so we can also just start typing motor interface dot stop in. That's all we have there. We have our animation, motor interface output, set point, motor interface set point, motor interface set point. Okay, and now we're going to release this version. So we've got all the properties and everything. We'll check just to make sure. Yep, we don't have any arrows going into these, so we can actually go through and just go ahead and delete that. We don't have any orphans. Everything's going into our motor interface. And we're going to release this version. It is version alpha 5. And you notice, I don't know if you've noticed this, but I'm keeping that box that says update instances in the project checked, because this thing just needs to be updated immediately. If you don't check that, you will have to manually go in and click update types in the project, or sorry, you'll have to go and update it somewhere else. Yeah, it'll be on that block. But anyway, so now let's go in and go to our root screen, our HMI, and we have these 2 instances here. I'm going to delete this. And in our interface now, it only has this motor interface, okay? And if we were to try to drag this like start input in, it won't let us because it's not the right data type, because it will only accept our custom data type now. So what we have to do is in our motor 1 control data block, remember when we made an instance of this motor control in our function block in our OB1, it brings up we had to make this data block here. Well, we're just going to drag this into here, and look at that, it accepts it. So this is motor 1 control, my interface. And remember, we we set that up in the basic starter. We called it my interface. The data type is my starter faceplate interface. So that's where those names are coming from. So now we drug that one tag in, and we're going to save and run that now and see how it works. Cross our fingers. This is live stuff here. So hopefully it still works. I mean, this should work no matter what, right? So that's green. Start, stop. Look at that. It's still working. And if you don't believe me, we'll actually go back into and go live into our OB1 and monitor it. And you'll notice that here, as we're doing this, watch these. They are not actually they are not changing. Those physical buttons are not changing, but the monitoring this is really not liking it. But you can see that those inputs are not changing, but the output actually is. So I found the limit. I found the limit there of what we can get away with in our connections. But I don't know why that's not stopping. There we go. It definitely did not like the connection between there, but as you can see, the start and stop, and those are not using those inputs. They are breaking through that. And so there you go. Once you figure out that sort of kind of like topic of, or that thought process behind making function blocks with the intent, express intent of using a faceplate in the future, you will be able to make these sorts of things to where you will have a real interface into your specific hardware. Like if you have a starter stop or something that like changes on every system, fine. But you're gonna have that faceplate, and you have a faceplate interface into it. And so this is your faceplate interface. And all you're doing at that point, you drag in a standard motor control faceplate out of your library, and then go to the properties interface, give it an interface, and then it works. And that's it. And you could have 100 different like applications or animations, connections, but your faceplate and your function block are designed to work together. And so that's what you have here. And I promise you, when I say hundreds of hours, I'm not exaggerating. Like you can go through, and when you calculate up how much a project is going to take, you sit there and you're like, all right, this is going to take this much, multiply this out, each one thing, here's all this, blah, blah, blah. And then you go through and you do this. It's repetitive. Drag, drop, and it's done. So we are at 2 hours. So I wanted the last thing to talk about today is the library functions that I've kind of been using and just kind of like overlooking. There's really 3 different places that you can have all of this information. Now, a faceplate has to be in a library, but a function block does not have to be in a library. It can just hang out. It can hang out up here in in your project tree. It doesn't have to be in a library. It doesn't have to like go over there into the other side over there and like be in a project, or sorry, in a library. But I want to point real quick out that there are 2 different places to and I noticed just now that when I'm dragging this in, again, I'm in my details view, and details view, drag it. That's how I'm collecting that interface. So go back over here, because talk about this project library over here. So types are you're inherently tied to a library. If you have a type, it is tied into a library. And a library is just a collection of types. And I know that sounds dumb and like I'm repeating myself, and I am, but the difference between a project library and a global library is just essentially a zip file. A global library is a bunch of types zipped up into a file, and then you can bring that type out of that global library into your project library that you can then make available to your project. So your project library is over there. You can bring out of the global library that's kind of like out of the bottom, you bring it out of there, you bring it up into your project library, and then that makes it available over into up here, this actual project. So this basic starter control, if I wanted to add it into the library to where, say you wanted to be able to just to protect this block from changes, make it a little bit harder, but then you also get version control. Because here's the thing, if I have been keeping all of my versions of this block here, well, I can actually drag in a version .3 if I wanted to. So this brings in this kind of version control. Now that I like this, I may go through and make a V1 and then a V2 block that has some other feature into it. And you can have a basic starter control for a V1 block and then for a V2 block as well. And they could all be under the same version management. So that's kind of the big thing of why you would want to use a project library. Well, if you want to make a global library, it is literally just as simple as saying, I want to make a global library and call it my global, and call it live. And okay, so sure, that's fine. Create that, and it should open it up to where I now have this. Yes, so you can see down here it is available, and it has the little pencil. That means I can edit that global library. And now if I wanted to go through and say I want my standard motor control panel function, faceplate in here, I can just drag it over into the types folder of this global library that I have. Okay. And if you'll notice, it imported all versions of that faceplate and the UDT PLC data type that's required to interface with it. Now, what good is that faceplate if I don't have my basic starter control function block, right? So I can just say on it, just drag this guy over into my project library, and it will begin the version control for it. And I've already named it kind of what I want, so I'm just going to say okay. And then now I can take and add that down into the types of my global library. So now I have this in a global library, and I can go through and I can say, all right, save the changes to the library, and then I can close that library if I need to, which is here. Yeah. So I can close that out, and that makes it available for other people. And now you could put this library on like a central server, and most people would open it just read only. So you would have your interns or your your junior engineers that aren't making these libraries, you would have them open this global library in read-only mode, and they have access to all of these faceplates that you've made. They can just drag them into the project. They can drag verified functions, verified control out of this global library into the project, and then hey, this junior engineer that doesn't have a lot of experience with PLCs, they have good code to build from. And all right, here is our standard set of diagnostics that we offer. Use this block, and it's going to have the correct interface. You're going to have all of this stuff. And then as they start to grow their technology and grow their experience and start working on projects to where they're improving, they can start from a base that is good. So I can't tell you how much time this project management software, version control, and project libraries, and faceplates and function blocks and all of this, how much time that it can save you if you have projects that you try to break it down into pieces that are small enough that, oh, I have a bunch of motor starters. Well, they control different things, but I want to start a stop. I want this basic input. I want this basic stuff. And so go ahead and write that code, get some good, like a faceplate associated with that function block, and then just go with it. And yeah, so this is, I know, a little bit more of one of the advanced topics, especially deal with HMIs, because it does tie together both HMIs and function blocks. And a lot of people will go through and make faceplates, and they'll make a faceplate that doesn't really save them a lot of time, because they're essentially saving it like cutting and pasting a block, or making a group like we did before and just cutting and pasting, and they're having to individually go in there and change all of those values. Well, that's what we did in the second half of this faceplate discussion, was make it to where your function block at your PLC is using a data type to where you can just drag one and then populate your entire faceplate. That's how you're going to get a vacation. We all want vacations, right? We all want to be on the beach. But I also know that you're the type of engineer that if you get free time, you're going to fill it up with learning more stuff. And well, in that case, there's plenty of other videos on this channel. And if you're not subscribed, please subscribe so that we can continue to grow and get these videos out more, because all of this content is for you guys. And I know that you're out there working, you're trying to work through these issues, and I promise you, the issue you're having, there's tens of thousands of other engineers that are probably sitting there struggling with that same thought, that same issue. So get involved, ask questions in the comments, get on live. Like, that's what we're wanting to do. And yeah, so next week, I'm probably, I keep coming in and kind of everybody's talking about winders, and get back to a drive topic or two, and kind of more of a principle of operation about how to actually control some motors. We've been working with PLCs and HMIs for the past couple of weeks. I think it's time that we need to get back to thinking drives and thinking moving the world, you know? And so next week, we're probably going to talk about starting from scratch and making, well, maybe not completely from scratch, but actually programming and thinking through the different ways of controlling a simple winder application. So like a tension control application to where we're winding up. And so some of the basics, and I know we've talked about some of the real deeper stuff, but yeah, it seems like people want some more of that. So if you can join us next week, I plan on it being at around the same time, 10 or 11 o'clock Eastern. And yeah, I'm so glad if you were able to join us live. Thank you so much for joining us live. If you weren't able to join us live, catch us on demand. hit it with a comment, hit it with a like, and to get this out more. And as always, whatever you do, keep asking questions, keep learning. That's how you're going to grow, and that's how you're going to become better. Never be afraid to ask questions. Till then, I hope you have a good weekend. Maybe you got a little bit of time off. Maybe if you're in Europe, if you are over in kind of the Eastern Hemisphere, hopefully you have already started your weekend, and hopefully you go back and watch some of these videos later on Mondays, and you'll have a good week next Monday. Maybe it'll enlighten your life then. But until then, we're going to end the stream now. Hope to see you next time. Take it easy. Bye.